The Nissan assembly plant in Smyrna, Tennessee currently installs speakers into vehicle doors manually, which is tedious and slow. We are tasked with developing a collaborative robotic solution to automate this process in a timely and repeatable manner. This project had several requirements and constraints. We were tasked with developing a tray to stage the speakers for assembly. We were tasked with picking up the speakers from the tray using a custom end effector designed by us, as well as handling the speaker between the tray and the door. Further, we were tasked with aligning the speaker with the car door, inserting it, and fastening 3 M8 bolts to finger-tight security on the door. These requirements were under the constraint of a cycle time less than 40 seconds, a UR10E cobot provided to us by Nissan with a max payload of 10 kilograms. The speakers are delivered to the assembly line along with the door they belong to. Various tests for the end effector were necessary, including friction testing for the finger pads, waypoint confirmation for the robot positioning. We also conducted error sequence trials for recalibrating the robot with respect to the car door. We approached the problem through designing, building, and testing various prototypes and programs to achieve speaker insertion. We've split this project into 2 distinct categories: the end effector, as well as programming of the UR10E cobot. We began the designing of the end effector with a Scott Russell straight line mechanism, which was actuated by a lead screw. After various tests, we determined that this required too much external actuation and was too large. Following this design and build, we converted to a cam follower mechanism, beginning with a 4-face and then transitioning to a 3-face follower. This reduced the need for extensive actuation and required only one stepper motor. Furthermore, we developed an aluminum machined plate holding 3 nut drivers that drove each of the 3 M8 bolts into the car door. This was accomplished with 3 DC motors, each controlled by motor drivers that could individually torque these bolts to finger-tight security. After various iterations of this prototype, we were able to condense into a 3-pronged clamping mechanism that successfully gripped the speaker. On each finger, we have included gripping pads that were tested extensively for their friction coefficients. This not only added friction to the gripping of the speaker, but added compliance as well, so that we could increase the force centrally applied to the speaker and ensure better gripping. In order to guarantee that the test would be repeatable, we designed and machined a truss attached to the back of the door stand. This reduced the amount of vibration when force was applied to the car door via the cobot. After extensive prototyping, we fabricated the entire end effector out of aluminum 6061. The programming of the robot was extensive, and we decided to use waypoints to determine where to pick up the speaker, how to carry it between the tray and the door, and how to insert it into the car door. In the end, we delivered a speaker tray laser cut from MDF. We designed and fabricated a 3-face cam disc to drive a clamp for grabbing speakers. We created a cradle waypoint on the UR10E path plan to improve handling of the speaker between the tray and car door. Thank you very much for your time, and thank you very much to our sponsors at Nissan, Brian Meadows and David Blaylock.